Okay, why don't we go ahead and get started? Welcome and thank you for joining us for Datamark session, Next Generation 9-1 Road Centerlines, More Than Just Lines. I am Sandy Dyer. I'm from the Datamark team, and I'll be the moderator and co-presenter for today's session. Before we begin, I do want to apologize that while we're going to use our videos for this introduction, we are going to turn them off actually for the session just to preserve bandwidth. We have found that doing video plus voice in a presentation can sometimes mess up the recording or mess up the ability for us to come through clearly. And we want to make sure that the audio and the presentation get to you. Also, I'd like to let everybody know that we are recording the session. All attendees have been unmuted for quality assurance purposes. We do encourage that you share questions with us either through the Q&A or through the chat, whichever you feel most comfortable in accessing. Jeff, my co-presenter, and I will be monitoring your questions, and we're going to answer them throughout the presentation. And then at the end, we'll pause to ask if there's any questions. I'd like to introduce you to my co-presenter, Jeff Ledbetter. Jeff, can you please share a little bit about yourself?
Yeah, hi everybody. Jeff Ledbetter here. I've been working. I'm a GIS nerd. It's my job. That's who I am, really. And I've been working in GIS for the better part of 20 years and in public safety, either in PSAPs, emergency operations centers, or in law enforcement or fire operations scenarios for the last 10 years. So I'm also a co-chair for the NENA GIS Data Transition Working Group, where we're working on an information document on how to transition GIS data, geared at E911 into the NG9-1 environment. So glad to be here with you today, and hope we can enlighten you on road centerlines.
Thank you, Jeff. And then again, my name is Sandy Dyer. I'm a public safety expert with Datamark. Datamark is a public safety team of Michael Baker International. I am historically from a public safety background. I started in 1990 as a public safety dispatcher and have had the pleasure of assuming multiple roles in 911 over the past few decades, from, again, public safety dispatcher to county 911 system administration, and then again at the state level to support 911 administration from a network, equipment, databases, GIS point of view. I also co-chair National Emergency Number Association, NENA, working groups. We do have public safety people that are joining today. I co-chair the real-time text working group. We have just went through the final portions of our document approval, and that should be coming out to you publicly in the next couple months. Super excited about that. And then I also co-chair NENA's GIS data stewardship for NG911. The current work group I'm on is focusing on road centerline development. Previously, I had been on the same working group, but focusing on PSAP boundary. Just a short introduction of us. We'll go ahead and get into today's agenda. So today we're really want to discuss how NG911 will use road center lines in the next generation 911 environment. And this is going to include the relationship between legacy and the boundaries, the attributes needed to support. So what are those attributes that the road center line needs to have? And then some unintended discrepancies we'd like you to look for. This will be a high-level discussion because next generation 911 is actually a very complex topic. So we're hoping that you walk away with enough information to get started, but we don't overwhelm you with too much information. So let's go ahead and get into what is next generation 911 and how it uses road center lines. So next generation 911, for those that don't know, is a GIS-based 911 system. And it's going to use the Civic address. Sorry, folks. It's going to use a Civic address from the road center lines layer, and we'll focus on that for today's discussion, to determine the caller's location and then query the corresponding PSAP polygon. PSAP's a 911 center polygon. So within the 911 system, you have various layers. You're going to have your road center line layer, you're going to have your site structure address point layer, And then for routing purposes, you have what's called a PSAP boundary polygon layer. And that PSAP boundary layer is the boundary that will identify what 911 center to route the call to. A PSAP is a term that, it's an acronym for Public Safety Answering Point. And the Public Safety Answering Point is a fancy term for a 911 center. So the road centerline layer will be queried to validate the caller's location, and then it will query the PSAP polygon boundary to determine where to route that 911 call. It's a point and polygon spatial query. And as described in this graphic from NENA's information document, GIS Data Stewardship for Next Generation 911, this is the PSAP boundary document. It's an information document. If you want to look it up, it's INF 028.1/2020. A Civic address or a geodetic location from a 911 call will provide the location for the system to query the corresponding PSAP boundary polygon to determine what 911 center will route the call. Let's make this a little bit easier. So the road centerlines layer is used to validate a Civic location. Now it is going to utilize the road centerline layer to validate a Civic location when a site structure address point cannot be found to perform this function. Either one, you don't have a site structure address point data layer within your 911 system, or it just can't find a corresponding address point to support the routing of that call. So when that isn't available, it will then go to the road centerline to query the road centerline to look for a geocoded location. So in this example, it's 1308 South Validation Avenue. The road centerline will then query the PSAP polygon boundary to determine what PSAP receives the call. And in this example, it would be PSAP A. Now, the 911 system does have the ability to also query a geodetic location by latitude and longitude. Obviously, if the call comes in with a geodetic location, it won't use the road centerline. There isn't any reason to use the road centerline. It will just query the polygon on its own and route the 911 call. So how does GIS get into the NG9-1 network? Well, it happens through the spatial interface. And let me take a step back. So you're going to work with if you're a GIS professional, you'll work with your 911 authority in order to gain access to the network. Now, either the GIS data can be provided to the 911 authority who will provision the data. Technically, it's the responsibility of the 911 authority to provision the data, although they can share that responsibility with the GIS data provider, or you may have direct access. But the spatial interface is actually the interface within the NG9-1 network that your data will be provisioned to. Now, the spatial interface provides the interface between you and your data and the location validation function and the emergency call routing function. The spatial interface is also going to transform your data into WGS84. So whatever projection it's in now, it's going to then provision it into a datum of WGS84. You don't have to do that prior to the spatial interface. Let the spatial interface do that for you. And then the spatial interface is also going to do some quality assurance checks before it even provisions the data to the location validation function and the emergency call routing function. It's going to check to make sure that it has everything it needs in order for these two other servers, the location validation function and the emergency call routing function, to work. So what is the location validation function? Well, the SI is going to provision your GIS data here. This server is going to replace what we use today in the legacy environment called the Master Straight Address Guide. And we're going to talk about that in a few minutes when we cover the legacy components. It's going to perform validation and routing verifications prior to a 911 call taking place. It's the maintenance portion of the network. It's going to, again, it's going to search first for a site structure address point. If it doesn't find that, it will geocode against your road center lines. It will make sure that should this become an active 911 call, that it would function the way it's supposed to. Now, the emergency call routing function has a complete duplicate of your GIS. When the spatial interface provisions the data into these two, it's just a replicated data set. They need to be exactly the same because you want to know during an active 911 call, which is what the emergency call routing function supports, that it was previously verified against the exact same database. You wouldn't want your call routing to happen in a different environment that you verified in the first place. Now, your next generation service provider, because there will be a next generation service provider that will support your spatial interface, your LVF, and your ECRF. They may have some individual rules around how your data needs to be developed to actually support their specific next generation core services solution. So it will be important to be a part of those discussions as you move forward on your move forward with your GIS development for NG911. So let's talk about why legacy matters in an NG911 environment. This conversation comes up quite a bit. Now, for those that don't have legacy 911 today, because we still have parts of the United States that don't have next generation, don't have 911. They have the ability to dial the digits 911, but they actually don't have the network that's needed to support it properly. And for those folks, the legacy components aren't going to be as important because you're going to go from known 911 today into a next generation 911 environment. Although there may be some elements of the legacy environment that you may want to carry forward even in your support of next generation 911, just simply because those are necessary fields or necessary information that you may want for other business needs. But legacy does matter for those that are in a current enhanced 911 legacy environment and are migrating to next generation 911. So let's give a little bit background on what happens today. So today's 911 system actually relies on two databases for call location and call routing, and that's called the ALI database and the MSAG. The ALI database, the Automatic Location Identification Database, includes all telephone lines, and these are landline telephone lines that have a physical connection to the 911 network that will allow it to be delivered to a 911 center. It includes the telephone number, the house number suffix or pre-directional. It has a street name, post-directional, community name. The ALI itself does include location-based information, but it actually is a non-spatial tabular database. Now, the Master Street Address Guide is also a tabular database. It's completely non-spatial. And it has, much like your road Centerlines file, it has the potentials. It has your low to high range. It has a pre-directional. It'll have the street name. Now, the street name and the street suffix reside all in one field. The community name, the state. It also has information called an emergency service number, an ESN, and the emergency service number actually tells the system this is the 911 center that receives the call. So in the next generation 911 environment where that road center line, where your road center line will be queried for the location, and then a query will happen to a PSAP boundary polygon, that point and polygon spatial query. In the legacy environment, because these are tabular databases, the MSAG actually assigns to your ALI location what 911 center that call is supposed to receive. So that's how the routing happens. Now, it's a little bit more sophisticated to that, and there's some more components, but we're really not going to go into the legacy 911 network today and how everything connects. Other than just a brief description on how that may look. So in your ALI database, you're going to have the phone number, you're going to have an address with a community, and it's going to query the Master Street Address Guide, who's going to find a range that ALI can be supported by with the correct street name, the correct community, and it's going to assign an emergency service number. And it's generally a 5-digit number. Can proceed by 0, so it could be 00004. but it's a 5-digit number for programming purposes. Now, to support the legacy components that happen in today's 911 environment, the NG911 GIS data model has legacy elements in it. And the legacy elements are brought forward and supported to assist with the transition to an actual end-state next-generation 911 environment. The reality is, as long as there's any legacy components that still reside within your next-generation 911 environment, whether that's legacy communication service providers like legacy telephone companies or anything like that, as long as they're connecting to any part of a legacy network, or if you have 911 centers that are still connected to a legacy network, then legacy still has to be supported. And then, of course, there's a function, and we won't go into it today, but called the MSAG conversion service, where it will utilize legacy components and use it to convert for an NG911 environment. Now, there is a lot of value in completing the legacy elements of your GIS data model, and Jeff's going to go more into what the data model looks like. This is just a portion of the data model focused on legacy. One is the build once, use it many philosophy. A lot of times your legacy components are going to be data elements that you support with other business needs. So while even if you don't need it for 911, legacy 911 or otherwise, you may need it for your permitting department, your planning department, your Department of Transportation, whatever the case may be. As a GIS department, you support more than just 911, and they may rely on these legacy fields in order to still capture the information that you're using for all these multiple business needs, but allow you to capture it in a data set that also allows you to support 911. So we're not asking you to build a completely different data set for next generation 911. That what's great about the data model is that it kind of allows us to be all things to all people, whether that's good or bad. The other key component to legacy fields, and probably the most important, and the reason that they're here is that, and while I don't have the identifiers here, this last field here is actually the field width. And the field width here is very different than it is for the next generation 911 data elements. This field width here is generally the field width needed to support today's legacy alley. So a legacy alley screen, a 911 screen, is what the dispatchers have presented to them, and it's actually the model that helps the data flow from the time the 911 call is received till it reaches the 911 center. And it's limited. It only has 512 characters. It's a very small screen that has to include a whole lot of information. And these fields are limited in order to support that legacy environment. It could be as part of your NG911 transition, they may have to consider delivering some legacy elements or continue to send the legacy alley to your 911 center because there are limitations in the 911 center that won't allow them to accept full NG911 capability. So completing your legacy components are going to be valuable to you. Now, probably the biggest reason that you're going to want to continue with legacy components is that we have to be able to run some validation checks between our legacy environment, how is 911 supporting us today, and making sure that our GIS is going to be able to support 911 tomorrow. And one of the ways we do that is what's called an MSAG to road centerline comparison. Now, the alley and MSAG to road centerline or site structure address point comparisons, actually per one of NENA's older documents, it's the standard is it's numbered 71501. It's called Synchronizing GIS Databases with MSAG and alley. It actually is looking for a 98% or better accuracy when you're comparing your databases. Now, even though the document itself is called Synchronizing GIS Databases with MSAG and alley, I personally don't like the term synchronizing. Synchronizing means that I'm going to merge these two databases together. And if I have two dirty databases and I'm going to synchronize them, I'm going to synchronize back to another just single dirty database. So I would rather you consider it a comparison. Compare the two and then look at what doesn't match and decide which database is right and fix the other one. Now, when we perform comparisons, we should remember there are two aspects of what we're trying to support with a 911 call. We're trying to verify that, one, the location is correct. So am I receiving a valid address from the 911 system? And am I routing it to the right 911 center? To just have a valid location, but you're sending it to the wrong 911 center doesn't do any good. But to send it to the right 911 center, but it's not an address that anybody can find, doesn't do any good. There's always two aspects of what we're trying to have our GIS do in an NG9-1 environment. And this is where these comparisons are going to help. The fallouts that you're going to receive are going to help you to compare that information. Now, specifically, an IMSAG to road centerline comparison is going to provide clarity to ensure that the GIS is performing the same function as the IMSAG. Can my 911 system in next generation 911 from the GIS perspective do the same thing that it's being asked to do today or better? It's going to identify where the IMSAG may need to be updated, or it's going to verify if the GIS may need to be updated. So for example, the low to high range in your IMSAG is going to get compared to your low to high range in your centerline. Now, the low to high in this IMSAG is 100 to 1399, while your actual GIS range is 1300 to 1399. Now, this may produce for you, from an IMSAG perspective, what I call false errors. 100 to 1399 isn't exactly wrong, but it's going to produce an error to say, hey, your road centerline and your IMSAG don't match. It's really going to be up to you whether or not you want to make any changes to either database. But the reality is, if this IMSAG only supports alley records with addresses within the 1300 to 1399, technically they're both correct. But you may want to actually make the modification to the IMSAG if this is the correct low to high in order to have them synchronize. And then to go back to what I had mentioned about, are we sending it to the right 911 center? Well, if the IMSAG says the ESN should be 400, but your road center line says it should be 500, which one's correct? Just because the IMSAG says 400 doesn't mean it's correct. Perhaps the GIS is, or maybe the IMSAG is correct and the GIS needs to be changed. I guess what I'm trying to offer you is, no matter what kind of error comes out of your comparison, I would like you to look at it holistically. Don't assume it's a problem with the GIS or with the IMSAG. Find out what's correct first and then correct the right database. The same with an alley to road centerline or site structure address point comparison. Again, we're seeking the 98% or better accuracy, and actually with your alley records, because these are actual physical addresses, 123 North Main Street, highly recommend you compare that to your road centerline and your site structure address point layer if you have them. Back in where I come from, we've been doing these validations for 15 years, and they would report their accuracy every year to us at the State 911 office in order to continue their funding. And I would have GIS people say, well, Sandy, if an alley is a physical address, why do I have to compare it to the road centerline if I have a site structure address point? Well, the biggest reason is that we need to make sure, especially in an NG9-1 environment, if that site structure address point cannot be located as part of an active call and it defaults to geocode to the actual road center line, we want to make sure that there's a road center line that is going to be able to support that 911 call, and that the road center line is going to route it to the same place that the site structure address point would route it. And Jeff will talk about the boundary relationship a little bit later. Not only that, but since 80% of our 911 calls are actually wireless in nature, meaning that you're going to receive an X and Y, it's not going to geocode to an address point or a road center line, but we still need to use these two data sets in order to, one, affirm that we are routing that geodetic location correctly and that we're still providing valuable information to the dispatchers. The reality is, the GIS used in the NG9-1 network should be the same GIS used in the dispatch center to support the dispatchers in routing their emergency response units. We don't want these two data sets to be in conflict. So what happens in the 911 center when they receive the location, they have a map in the 911 center and it will plot the 911 call. Well, they don't dispatch based on a latitude and longitude. They actually will look at their map and say, you know, this will be near the intersection of, or this is in the area of this physical location. And that's why it's important that we keep this information in sync. Again, like we mentioned, what we're looking for is to make sure that the road center line is going to be able to geocode properly. And we want to know that it's routing to the right place. Remember, valid location, valid routing. We want both of those things checked. Okay, so at this point, I'm going to turn it over to Jeff, and Jeff is going to actually jump into the GIS data model for next generation 911.
Yeah, great. Thanks, Sandy. We'll move on to the next slide. We want to introduce the fact that there is a NG9-1-1 GIS data model as a NENA standard. Again, NENA is the standards making body for Next Gen 911. And this was established in 2018 and in fact is already under revision in a V2 working group as of now. That'll probably be available in the world a year from now or so with a very specific scope. What I want to point out about it is that it requires thoughtful interpretation. In other words, I've had many conversations with GIS nerds where they say, you know, just tell me what the schema needs to be. That's all I need to know. I don't really need to understand all that legacy stuff that Sandy just explained. I just need to know what the schema is going to look like. And the fact is that if you don't understand a bit more than what the schema needs to look like, that is why the schema looks the way it does, then you're going to have a hard time actually implementing the data in the way that it needs to be implemented. It is a good document that demonstrates what the schema should look like, but also gives you the right field widths, the mandatory fields that are mandatory, optional, and conditional. We'll talk about those in a second in more detail. And these legacy fields that Sandy referenced earlier, the more I've gone into adjusting customers' data so that they're ready to be prepared to implement their GIS data in a next-gen system, the more I've realized that these legacy fields and how you populate them, particularly in a road center line, but also in an address point layer, are really important as they actually allow the quick interpretation from one format, that is the Next Gen 911 PIDFlow format, to the legacy format of an MSAG or ALI spill. And if you don't have this connection back to your legacy databases in place in your GIS data, not only is it going to not work right in the Next Gen 911 environment where those legacy elements are used, but you're also going to have a hard time connecting your GIS data to your legacy databases in a way that helps your quality control and quality assurance of your data moving forward as you normalize that data for a next-gen environment. Then there are also elements in here that aren't historically tracked, such as state or country. So again, in a 911 environment in the past, we were able to live on an island. Even as GIS data came into play with E911 as location of wireless devices became more important, you could still maintain your own GIS data set and your legacy 911 databases in such a way that you could make changes in there and it didn't matter because it didn't connect back to other business cases, other business uses, other enterprise systems within a given city, county, or other jurisdiction. Those days are not around for much longer, and certainly in the next gen environment, you're going to be dependent on a data supply chain that makes it such that it is a wise move to enable the free flow of data that doesn't break other enterprise systems and data connections and those historical elements of state or country, the field widths that are wider or narrower than in those enterprise systems are going to have to be dealt with. The parsing that is different, very different in terms of granularity, also brings a challenge that's going to have to be dealt with. And this is what I mean by requiring a thoughtful interpretation. It's not just to give me the schema, let me see the grid in this document, and I create a new schema, or I just download the one from the NENA website and implement it, but rather it's a thoughtful interpretation about how do we get data into this schema for this purpose, but also maintain it in a schema that allows us the flexibility to service all of our enterprise systems with this same GIS data. So let's dive right into the details of the schema. There are address elements that are going to be more granular than you've seen before. Things like address number prefixes in address points, or to your left to and from addresses, your parity. A lot of our clients as well have been bringing in data sets that didn't track parity before because they weren't made for these purposes either. That's a new field to tell and track whether you have both even and odd on a street, or just even on one side, or just odd on one side. Next, some examples of these elements. And I want to point you to what we have circled in red here. The Civic Location Data Exchange Format Standard is another NENA document, NENA STA 004, that is useful not only for the fact that it is the location conveyance format for the PITIFLOW, or the Next-Gen 911 location document, location object is what I mean to say, but also because it's chock full of great examples of how you would go about implementing address number elements, street name elements, and other legacy elements to get them to work with the CLDXF. And this is one example of those tables where it demonstrates ordinary integer address numbers with suffixes like fractionals and letters, address numbers with prefixes. Now those are not, there's not a typical sort of format in the United States of address numbers, but it's more rare than it is not rare. It sounds strange, sorry. It's more rare to find prefixes than it is suffixes. And so in a lot of places, you'll need neither prefixes nor suffixes, but some places you'll need both. There's a myriad of address numbering systems, as you kind of see in the bottom, where they also use map grid references or township range type references in their address numbers as well. Moving into the next slide, we see the street name elements that are in this GIS data model. And we see that it is parsed very differently than the traditional street name elements are parsed, especially in other enterprise systems, where you'll typically find a pre-directional, a street name, a street type suffix, and a post-directional. Those 4 fields exploding here into 8 because of the CLDXF and because of that PITIFLOW format that the internet uses to share around location data. Now it becomes a pre-modifier, a pre-directional, a pretype, and the pretype separator if necessary. There's a great example of a conditional field. The pretype separator is going to be used in probably a minority of instances, but everywhere there is the need for a pretype separator, it is mandatory that it's populated in that field. Followed by a street name, a posttype, a post-directional, and a post-modifier. And then those legacy street names that help you connect your legacy databases to your GIS data in that typical four field format. And the thing we've learned about legacy street name fields, and you can go on to the examples there, Sandy, is that because of the wide variety of formats that MSAGs and alleys occur in, you have to pay attention to your particular IMSAG, your particular ALI format, and be sure that to the best of your ability, that format is observed within these legacy fields. Moving into the examples here of street name elements, you see that there are many ways. On the top, C.2.1 kind of show your typical examples or your uncomplicated examples as the document refers to them. Street name and street name post type, maybe with a pre-directional, maybe with a post-directional. But there's a myriad of other complications that particularly involve using pretypes. Pretypes are especially prevalent in foreign language road names, such as Spanish and French, but are also in English, as you see the example of Avenue A. Avenue A is particularly popular where a place was addressed with a grid system and using letters to be part of that grid. Avenue would be a pretype and A be the street name. And an example of, we don't have an example of that next, do we? No, we don't. An example of using a pretype separator would be my favorite example in Coronado, California, right along the beach. There's a road called Avenida de las Arenas, the Avenue of the Sands. Avenida being the pretype, de las being the pretype separator, and Arenas being street name. It also occurs in English. The famous Avenue of the Americas in New York City is a good example, where Avenue is the pretype of is the street pretype separator, and Americas is the street name. You also see an example here in Avenue C Loop, where we have a pretype and a posttype. We had one particular client that came up with a number of these as they were in California, and they had a number of Spanish language names, and they came up with Strada, I forget the street name, but it was Strada, let's say Rosa Street, Strada Rosa Street. And Strada is actually the Spanish word name for street, so it was Street Rosa Street. And so the point of that being, not that there's a bunch of weird street names out there, we all know that, that goes without saying, but there is such a thing as using your wisdom to apply this this parsing format. And the CLDXF and therefore the GIS data model allow for and require there to be flexibility for local addressing authorities to do the right thing with the parsing of their names. One example that we've had in our GIS data transition working group that's come up is a street name called Old North Church Road. Well, it was Old North Church Road because there was the Old North Church used to be on that road, or maybe still is, but old became a pre-modifier, and if you were to strictly apply this, north would be a pre-directional, and church road would be the street name in post type. But the addressing authority knew the story behind it, and the local wisdom and the local knowledge is that rather than breaking it up that way, Old North Church would be the street name and road would be the post type. Now that doesn't give anybody an out for having to parse these things. You don't lose the operational efficiency, so that you don't lose the operational efficiency that comes from parsing them this way, and the granularity that provides flexibility but more work to create it.
Jeff, a couple questions came in. One is, how do you handle domains for pretype if the pretype and posttype are the same?
Yeah, domain is a good question. There actually is a NENA registry, which shouldn't necessarily be considered a domain, but it is a pretype and posttype registry where if you have a pretype and posttype that isn't in there, they ask that you register it with NENA so that it can be a recognized pretype or posttype. It does serve as a good starting point for domains because it is a registry of pretypes and posttypes. And so my recommendation would be to take that NENA registry for pretypes and posttypes and then create a domain from it, and then do a little bit of checking for deltas in your road centerline set and see if that domain covers everything it needs to. That's how I'd build a domain. There certainly is an example of a CLDXF compliant GIS data model compliant geodatabase that you can get from NENA. And that's another good place to start on domains. But you're always going to want to make sure that you take that domain as a starting point and not as an ending point.
And then another question came up about the naming of on-ramps and exits for freeways and controlled access highways. Mm-hmm. And this is a topic that the Road Centerline Working Group has taken up and is providing data stewardship guidance for. The document's still in draft mode. And so while that information is available, because it's in draft, it hasn't been final approved yet. Unless, Jeff, for some reason, or do you have anything to offer on that topic?
I can only say that just kind of using your best judgment at this point is the right thing to do. For me, if you've got a post type, that kind of stuff can be a post modifier. Sometimes people want to use a pre-modifier. It would be a good example of a modifier. That's just sort of my wisdom on it, but it actually is in the registry. Things like ramp, the word ramp is in the post-type, pre-type, post-type registry. Mm-hmm. So it would be a valid it would be a valid post-type or pre-type if you wanted to use it that way. I don't think anybody could argue that you weren't standard compliant if you did that. But at this point, short of the guidance that's going to come out in that GIS data stewardship document, that's how I would approach it.
Okay. And I do have one more question, but want to point out to everybody the examples that we're offering it from the Civic Location Data Exchange Format document. These are like, this is just a screenshot of a portion of a page, and that document has pages and pages of examples of how you may want to parse your data. For each one of these, for each one of the elements, there's just pages and pages of it. And we'll be happy. I'll find that link and I'll share that with you in the chat. The last question, Jeff, before we move on is, do ESRI geocoders work with these additional fields, such as the street name pre-type?
I would say that my guidance would be to create a custom geocoder. You can certainly do that within the Esri software. But I would want to create my own so that it was 100% compliant, and I would lock that down to be checking every field and not giving it any kind of fuzzy control, so that you could test appropriately how any geocoder built into a next-gen core service software functional element might read your data. So it's highly likely that you could get one out of the box from Esri that might do the job, but you'd be really well served if you took the infrastructure that was in place from Esri and did a custom locator.
Okay, thank you, Jeff. So folks, I did post the link to the CLDXF document, and I will also post a link to NENA's standards page, which includes all the standards, requirements, and information documents that NENA has for all 911 elements.
Okay. Next, we'll move into the community name elements. Community names are an interesting topic. You know, as I mentioned before, we're going to have country and state collected before, where you may not have done that before. County, most people kept county, some people didn't, depending on their setup. But you have the additional community fields of incorporated municipality or in-community, unincorporated community, unincom, and neighborhood community that are optional. I'm sorry, in-community is not optional, it's mandatory, but uninc-community, unincom, unincorporated community, let me stop talking in field names. Unincorporated community and neighborhood community are optional, along with postal codes and postal communities. Now, the place in which you would want to use these unincorporated communities is where you've got some places within, I lived in San Diego, and they had many unincorporated communities that were kind of like cities, but the county actually provided all their government services. Places like Ramona and Hamul are examples of those in San Diego County, where there wasn't an incorporated city, but everybody knew it as Ramona. And so in that case, you may have an incorporated municipality of San Diego County, but a unincorporated community of Ramona. And throughout New York City are many good examples. You can drive onto the example page here, Sandy. In New York City, where the neighborhood community comes into play, it must be on the other one, but we'll get there. We'll see that. Yeah, so you've got an unincorporated county in Alaska with a USPS code of North Pole. That's a good one. You've got boroughs and things like that that can go in postal community. Now, I usually stand up on a soapbox, and talk all about how public safety, addressing, and road naming doesn't have one thing to do with delivering envelopes to a mailbox. And I'll stand by that today as well. But I will say that capturing that postal community may help you if, in fact, your MSAG communities bear a relationship to those postal communities. And other times, that postal community may help you as well with a geocoder to distinct 123 Maple Drive in a given postal community of Ramona versus the city of San Diego, say. So there are times in which the USPS code, community name rather, and postal code can be useful, but I'll still stand by my statement that public safety addressing and road naming has nothing to do with delivering envelopes to boxes. So that's our adventure through the actual data model itself. Let's talk a little bit about the road centerline and boundary relationships.
And I do want to apologize, been answering questions at the same time. So I apologize, Jeff, on moving your slides along. Another question came in as, can you please describe the difference between what would be a unit number versus an address number suffix? I see half being used as an example for an address number suffix. Could that be a unit? We have many homes with a main address and then also a half.
Yeah, that's a great question. And again, I think that's something that is up to the local addressing authority, is the long and short of the answer. But for me, prevailing wisdom needs to be, generally speaking, that those should be a unit. But it may be most appropriate to have it be a address number suffix if there is additional units on top of that, because that does occur some places. In other places, I see things that are not necessarily structures, but they're more infrastructure being used as a address point suffix. So for instance, the 1/2 fractional example brings back memories of when I worked for Greater Harris County 911 in Houston, Texas, where we had a statutory addressing authority that was the electric utility provider. And they insisted on giving an address, a fractional address, to every piece of electrical infrastructure that was out in the field. So if there was an emergency transformer for traffic lights at 101 Main Street, they would name it, they would number it 101.5 Main Street. If it was a pole, it would be something like an 8th, and they had a code to it. So in that case, the addressing authority has said this address belongs, this fractional belongs as an address suffix, and so my data reflected that. But I argued with them regularly that they needed just a whole number address. and to pick an infill, but they wanted to use that as kind of a code to them to know that that was not a house or a structure or a community building, but rather it was their infrastructure. So that's one example of where the addressing authority can say this is a suffix. But by and large, if it's a different dwelling place, if it's a different commercial unit, those belong to my judgment in subaddressing. And so what you hear throughout these examples is those, in my judgment, in my opinion, and the fact is that this standard, though it is a standard, is not going to make everything black and white. And so we still have room for best judgment of addressing authorities, and that'll be necessary moving forward. And it'll be interesting to see how in places where judgments differ on similar questions, if it causes any trouble with the routing of 911 calls. There's no reason to believe it would, as ECRFs have the ability to kind of make fuzzy interpretations of locations to get the call routed. But it is going to be interesting to see if there's any further guidance as implementation speeds across the country.
Okay, so we have a couple more questions, and I know that we have more to move on, Jeff. And so if folks are willing to hang out, I mean, we're not even close to completing the presentation. So how to build a good locator? Do you use composite with street and other data is the question. I hope I'm asking that correctly.
Yeah, I think it depends on what the use of the locator is. If the use of the locator is to test your data and see if it's ready to move into an ECRF and an LVF, or feed an MCS to connect to the legacy elements, I would say composite really isn't the right thing to do, because you're going to want to test your data against a really strict source, which should be, your gospel, so to speak. If the purpose is to kind of then see how, if the relationships between your address point and your road center lines would work such that if it doesn't find an address point, it then checks against the road center line, I would say a composite locator is a smart thing to build in that case. So it really depends upon the purpose of the locator that you're building and what you're looking to get out of it. But I would say that as a GIS professional, be prepared to use your full toolbox to ensure that your GIS data is ready to route 911 calls.
So they did clarify, and the question is more about new address and into the map and for geocoding purposes.
Sorry, say that for me one more time.
So the question that originally came in is how to build a good locator. Do you use composite with street and other data for geocoding, like a new address into the map? I hope I'm reading the question correctly. And if I'm not, please feel free to rephrase your question so I'm not hacking this up for you.
I think I get what they're saying. I see the Q&A box here.
Okay.
You're saying, would it be smart to create a composite locator that would actually create the location as you entered a new address? And I would say yes. In that case, you're going to want to use every source you can to actually locate that in the correct place. And then, of course, any geocoder that's going to be creating points for you, you're going to want to run real tight QC against and make sure that, to the extent possible, your address points that come out of that geocoder are going to be located on the structure, and if one exists. So I would say that that is a good way to do it if you're going to use it as a data generator.
Thank you, Jeff. And folks, just want to restate, the GIS data model is well, so many of NENA's documents are such a great resource. But if you're looking for a place to start with GIS data model, pull the schema out, understand what's required of the schema. Mandatory has to be there in order for the NG9-1 network to work correctly. Now, I do want to offer at the beginning of this, I didn't talk about everything there has to do with NG911 because it's a very, very large lift. And we provide other training that talks about every aspect of NG911 to the extent that GIS is applied. But to give you a better understanding, we just pulled out a single GIS element of that for you. So you understood how your data got into the network, but didn't talk about the network completely. Within your GIS data, it's not just about representing a location, but it's actually communicating with the network to help that call flow. And it actually performs such a valuable part. The data schema has all that information, tells you these are the mandatory fields and these need to be completed in order for the network as a whole to work properly. Conditional, if you have it, it should be there. Optional is just that, it's optional. In concert with that, not only does the GIS data model have tons of description information below the data schema. I tease GIS people all the time. They go to GIS data model and then they stop at the schemas, but they don't read further down. There's lots of great information in it on how to apply a lot of the information. But CLDXF also does as well. Tons and tons of information that are really going to help you to take your unique scenario happening in your community and find a way to apply it in the new model. They've really done a great job, all of the work group members that participate, which is a compilation of folks like you. They join these work groups and provide their valuable knowledge and insight. I just love it, into how to help you so you can flip through a page and find that resource. I'll get off my soapbox about that. I'm a huge advocate for NENA and the resources they provide. But to get back on track, sorry, Jeff, RCL and boundary relationships, let's talk about those.
Yeah, let's talk about those. And I think, Sandy, at the end of this little section, we probably would be a good break point. Even though we've got a lot of good other information, I would say stay tuned into our webinar feed, and we'll be sharing the rest of that content in another session. So in terms of talking about road center lines and boundary relationships, it really actually is a critical relationship in terms of routing 911 calls in the ECRF, because if you have a road center line that geocodes and you have a boundary to do the point and polygon query, you have everything that an ECRF needs to start doing its job. That's a good start. Now, address points are required. They were added later to the GIS data model, and appropriately so, because they clarify the routing that may confuse the geocoder routing, point location of an address. And this slide here with the fish bones demonstrates exactly that. If you could bring in the boundary there, Sandy. Road centerline and corresponding address points and polygons should find the right boundary in the ECRF. And so you have to check for discrepancies between the Civic location layers and the polygons. Lack of consistency can have an effect on call routing, as is demonstrated here. You see the green boundary polygon, and you see some address points that would, if we said that that green polygon is PSAP A, the points would route to PSAP A, but the geocoded location would route to PSAP B. You can see there's about 3 points on that address point, on that road center line that would geocode into the wrong PSAP because of the ranging on the road center line. And so it's important as you create your road center lines and you think about questions like, do we have an actual address range, or do we have a theoretical address range? And you examine the need to break every road center line at the change of attribution. That's a critical thought process to undertake, is that the simple fix to this problem is to break that line at the change of attribution and bring the address ranges to adjust so that those 3 or 4 on each side geocode to the same place as the address point is located in, and therefore give a consistent answer. And so there is an undeniable relationship between road center lines and boundaries. Moving into the next slide, you see as you create the boundaries and update the boundaries that you start with, that topological coincidence is also necessary for road center lines. everybody everywhere has too many boundaries that are driven by the location of a road center line or an offset of that road center line or the right of way of that road, which may or may not be indicated appropriately by the center line itself. And so these splits that need to occur at the change of attribution should include the boundaries. And sometimes you're going to have to dig into meets and bounds and things like that and make sure that the offset of the road center line that you've agreed to is sufficient, that the right of way is appropriately represented by that polygon and things like that. And so in addition to that, offsets, a different type of offset, may be used by next-gen core service providers in order to sort of provide some of that fuzzy logic and fuzzy routing to handle things like the situation we saw with those fishbone graphics, where there are some along the boundary that may have some trouble routing. And I don't have time to go into that today, but that's an interesting topic as well, those different kinds of offsets. Moving into the next slide, we can see that the boundaries are different types of boundaries come together to create the layer cake, right? And so for the public safety people, they say, I'm looking at the map, they're looking at the layer cake of GIS data. And as coordinates come into that layer cake and are mapped into the system by the NGCS, how you manage your boundaries and your road center lines with those boundaries has major impacts on how this geodetic routes to the right PSAP or to the wrong PSAP. And so the point of this is that you don't want to have unintended discrepancies. Not just discrepancies, you're never going to have 100% perfect GIS data, but you don't want to have unintended discrepancies. This example right above the geodetic location demonstrates where sometimes you may need to have an intended gap in that polygon. You may need to have a road go through it because perhaps there's no service provider there. If that's an ESB, perhaps there's no fire service provider. I can come up with a couple of situations that I had to deal with when I was in the seat where there were nothing but fights about who's going to respond first to a particular area because it wasn't well supported by tax dollars in an unincorporated county, but yet it was an island surrounded by cities and the county fire department couldn't get there efficiently. And so there were a lot of fights about who would respond. So there are cases where you may want to have an intended discrepancy, but there are no cases where having an unintended discrepancy would be a good thing, anything but an opportunity to be sued. And so I think we'll go ahead and cut it off there, Sandy. What do you think? And let you know, check in. I don't see any more Q&As there. Let you know that we sure do appreciate your attendance here. As you can tell, Sandy and I are passionate about making sure that everybody out there is well equipped and supported in this difficult transitional time. Not difficult, that sounds dramatic, doesn't it? It is, though, a fun challenge to dig into it, do the right things the right way, and everybody has their own needs to be met. So these are generic guidance that we're giving here, and we hope that it's been helpful for you, and we'd love to help you if you have any specific questions that you're wrestling with. So I don't know, Sandy, if it's possible to get on to the last slide, or is it the last one? Oh, the last one. Yeah, where we have webinars.
Oops. Haha. It is if I don't bounce all the way through it. Again, folks, apologies. We didn't realize that we would have so much interest and so many questions. These are upcoming webinars.
It's a good kind of surprise to have, and so we're glad to have it. But next webinar will be about strategic planning, because everybody knows that a plan, what is it? A goal without a plan is just a wish.
Exactly.
And so if you don't get things thought through strategically, you're going to have rework, and there's a lot of value in doing it strategically. before you go in tactically. And so that'll be next webinar. Successful grant writing in December will be great for all of the 911 directors out there to kind of look at, even GIS managers that may be trying to get somebody else to help them pay for all the work that needs to be done. And then the NENA standards, I bet the content that we didn't get to today is going to be covered in-depthly on December 15th under address points and boundaries, because we can easily sort of roll some of that RCL stuff in there too. So register for those. Look forward to seeing you there, and appreciate your attendance today, and reach out to us if you have any questions.
Okay, and we do have questions about the slideshow presentation being available. I believe that's possible, but let me, I do need to check on that. We will follow up by email if that becomes available. The video will be available. Our apologies, we weren't able to get into everything. It's a good problem to have, right? But reach out to us if there's any other type of training that you think you may want. We're happy to provide it, and we hope to see you with our upcoming webinars. Have a good one.
All right, bye-bye.